Hello friends, in today's lesson we will talk about the challenges and solutions for the microservices, tips and tricks. Myself Ambrish Jha, I am working as a Java Technical Project Manager in a reputed organization. In this lesson we will talk about the various challenges we encounter in the course of Spring Boot application development. So we know that the Spring Boot microservices or microservices architecture is a new buzzword in the market. Everyone wants to transform their monolithic application into the smaller pieces of independent applications called microservices. But I agree with the fact that this is the most uh, flexible and convenient approach today's, but it comes with challenges also. So the first challenge we may encounter during this kind of development, application development, is the data synchronization, data consistency. If our transactions are spanning around multiple microservices, then this data synchronization can be the biggest challenge we face in this microservices design. Event sourcing architecture can address this issue using the async messaging platform, and the Saga design pattern can address this challenge also. So the problem statement is like how to implement transaction that span services. Solution. Solution implement each business transaction that span multiple services is Saga. A saga is a sequence of local transactions. Each local transaction updates the database and publishes a message or event to trigger the next local transaction in the saga. If a local transaction fails because it violates a business rule, then the saga executes a series of compensating transactions that undo the changes that were made by the preceding local transactions. Uh, there are two ways of coordination sagas. One is the choreography. Each local transaction publishes domain events that trigger local transaction in other services. And other one is the orchestration. An orchestrator object tells the participant what the local transactions to execute. We can take one simple e-commerce application example that uses this approach would create an order using a choreography based saga that consists of the following steps. Like simple, the first step is the order service which receive one post request to create an order, and the order will be in default pending state. Then it emits an order created event to the system, and the customer service event handle attempts to reserve the credit. It then emits an event indicating the outcome, and finally the order service event handler either approve or reject the order. Next major challenge in the microservices architecture is security. An API gateway can solve these challenges. There are many open source and enterprise APIs are available like Spring Cloud Gateway. Eureka is also another API gateway. FG, WSO2, Kong, Okta, and public cloud offering from AWS, Google Cloud Platform, and Azure, etc. Custom solutions can also be developed for API security using JWT token, Spring Security, and Netflix OSS Joule. Communication among the services also play a very important role. There are different ways to communicate microservices. 1. Point to point using API gateway, messaging event driven from platform using Kafka and RabbitMQs, service mesh are the another example through which we can provide a way to communicate among our services. Service discovery will be the next challenge we may encounter during the microservices. Service discovery, this will be addressed by the open source Istio service mesh API gateways we have discussed in earlier slides. Netflix Eureka APIs. It can be also done using Netflix Eureka at the code level. However, Doing it in with the orchestration layer will be better and can managed by these tools rather doing and maintaining it through the code and configuration. Data staleness. The database should be always updated to give recent data. The API will fetch data from the recent and updated database. A timestamp entry can also be added with each record in the database to check and verify the recent data. Caching can be used to customize with an acceptable eviction policy based on business requirement. Distributed logging, cycling, cyclic dependency of services and debugging. There are multiple solutions for this. Externalized logging can be used by pushing log messages to an async messaging platform like Kafka, Google PubSub, ELK, Elasticsearch, Logtest and Kibana, etc. Also a good number of APM application performance monitoring tools available like Wavefront, Datadog, AppDynamics, AWS, CloudWatch, etc., which can be used to aggregate your distributed logs among the various microservices you have created to fulfill your business requirement. It is difficult to identify issues between microservices when services are dependent on each other and they have a cyclic dependency. Correlation ID can be passed by the client in the header of REST API to track all the relevant logs across all the pods Docker containers on all the clusters. Testing. This issue can be addressed with the unit and integration testing by mocking microservices individually or integrated dependents APIs which are not available for testing using WireMock, BDD, Cucumber, integration testing tools, etc. Monitoring and performance of microservices plays vital role in the successful delivery of microservices based projects. Monitoring can be done using open source tools like Prometheus with Grafana APIs by creating gauges and matrices. GCP Stackdriver, Kubernetes, InfluxDB combines with Grafana, Dynatrace, Amazon CloudWatch, Visual VMs, iProfiler, Your Toolkit, Graphite, etc. are the various examples you can use in your project. Tracing can be done by the latest OpenSense Open Tracing project or Uber's open source Jigger. It will trace all microservices communications and show request response error on its dashboard. Open tracing Jigger are good API to trace API logs. Many enterprise offerings are also available like Tanju TSM etc., which you can explore. DevOps support. Microservices development and support related challenges can be addressed using a state-of-the-art CI/CD DevOps tool like Jenkins, Concourse, support YAML. Spinnaker is good for multi-cloud deployment, PaaS, Kubernetes-based solutions, TKG, OpenShift, etc. Fault tolerance. Istio services mesh or Spring hystrix can be used to break the circuit if there is no response from the dependent microservices for the given SLA, ETA, and provide a mechanism to retry and graceful shutdown services without any data loss. So here is the summary of some of the problems encountered when simply calling a service, like failure or latency, retries, how many retries a service can do to get the response from the underlying services, routing, where to go, how to go, service discovery, who will going to serve us, and observability. Microservices is about making changes quickly to your system. If you cannot trust your system, you are going to hesitate about making changes to it. You will slow down your releases. If you deploy slower, this means you will have longer cycle times, which means you will probably try to deploy bigger changes, which is not a good ideal solution or the situation in the microservices design on development. We have selected microservices approach because we want to segregate different type of activities into different microservices, and small independent team can develop and deliver in short span of time. But if they hesitate to submit their changes or they take more time, then the all purpose of breaking the solutions and doing something in agile methodology will fail. Finally, in this slide, we are recapping what we have gone through with earlier slides. So, service discovery implementation, adaptive routing, client-side load balancing, automatic retries, timeout control, back pressure, rate limiting, matrix stats collection, tracing, A/B testing, traffic slapping, request shadowing, service refactoring, request shadowing, service deadline, timeout enforcement across service calls, security between services, edge gateway or router, surgical fine per request routing, forced service isolation, outlier detection, DDoS attack detection also, fault tolerance, injection delays, dropping ingress egress packets, internal release dark launches, all other things are we need to solve and we need to take care during the course of application development using microservices architecture. Thank you for watching this video. Hope you have get some idea what the major challenges you may face during the microservices application development. Thank you for watching. Please subscribe my YouTube channel for watching more videos. Do like and share. Have a nice day. Bye bye.